In this video, we'll be introducing the dot product. The dot product of two vectors is the sum of the product of their first components and the product of their second components. That is, the dot product of two vectors, u being AB and v being CD, is denoted u dot v, so it's like a bold-faced multiplication dot, you'll see it kind of big, is equal to a times c plus b times d. Please note that the dot product of two vectors is a real number and not a vector. Dot products are used to determine the angle between two vectors, derive geometric theorems, and solve physics problems. So let's find the dot product for some pairs of vectors. Don't overthink this. All we're going to do is multiply our first two components together, our second two components together, and then add those two products. So we're going to have negative 3 times 7 plus 8 times negative 5. It's negative 21 minus 40. We get our dot product to be negative 61. In the next example, you'll notice that our vectors are written in our AI plus BJ form. The first thing I would do is rewrite it with my angle brackets. Our first vector is 2, 4, and our second vector 0, negative 1. And now we'll find the dot product. We multiply our first components together, multiply our second components together, and then add those two products. 2 times 0 is 0, plus 4 times negative 1 minus 4. We get a dot product of negative 4. Now, like most things in math, we have properties that go along with it. So these are our 6 dot product properties. So say we have vectors u, v, and w and a real number k. Our first property tells us that dot product is commutative. U dot v is equal to v dot u, and that makes sense because we know that both multiplication and addition is commutative, and the dot product involves those two operations, so it would make sense that a dot product would be commutative as well. Property number 2 says that we can distribute the dot product over a sum. So if you have u dot the sum of v plus w, we could add those vectors together first and then dot it with u, or you can distribute the dot product and get u dot v plus u dot w. And then property number 3, it's just pretty much the same thing as property number 2. We're kind of just distributing from the backside. So vectors u plus v dotted with w is the same as u dot w plus v dot w. But again, personally, I'd probably add the vectors together first and then dot it. In property number 4, we have a vector u that's being multiplied by a scalar dotted with another vector. So here it kind of shows the associativity of the dot product, that we could choose to do the dot product first and then multiply by the scalar, or we could switch it up and multiply the second vector by the scalar and then dot it with the first one. Property 5 says that if we dot the 0 vector with another vector, we get 0. And that makes sense since the components for our 0 vector, they're both 0. And then our last property says that if you dot a vector with itself, you get the magnitude of that vector squared. So in our next example, I've given you 3 vectors, and we're going to perform some dot product operations using these properties. So we have vector u being negative 2, 1, vector v being 3, 4, and vector w being negative 5, 12. The first thing we want to do is find u dotted with the difference between the vectors v and w. I could distribute this dot product, but personally, I'd be inclined to subtract u and v first and then dot that vector with vector u. Remember, when subtracting two vectors, you're simply subtracting the components, the first components, and then the second components. So 3 minus a negative 5 is going to be 8, and 4 minus 12 is negative 8. So what we've done so far is just v minus w. Now we're ready to dot this result with u. So we're going to dot negative 2, 1 with 8, negative 8. So you'll notice when I drew in the dot for dot product, I made it super bold. I encourage you to do that so it's not confused with any other operation. So we'll multiply our first two components together, our second two components together, and then add those products. That's negative 16 minus 8. We get a dot product of negative 24. In part B, we need to dot u with 3 times vector w. I'd be inclined to do the scalar multiplication first and then dot that result with u. But as we saw in property number 4, we can kind of rearrange it however we want and do whichever order first we care to. All right, so I'm going to do the 3 times w first. That's going to give me the vector negative 15, 36. And then we'll dot that with our vector u. So let's dot negative 2, 1 with negative 15, 36. Let's multiply our first two components together. Negative 2 times negative 15, our second two components together. 1 times 36, and then we'll add those two products. This is going to give us positive 30 plus 36. We get a final answer of 66. In subsequent videos, we'll go into more detail on the dot product.